Hi friends, how are you doing? I hope that your preparation is really going on very well, right? So we have already done one session on permutation and combinations. This would be our second session. After that, we would have one more session on permutations and combinations. But before starting this session, let's do a 1 minute meditation by watching the second hand of a clock, right? So I've just opened a digital clock here, and let's watch it. So that's it. It might be a very long 1 minute for many of you, but believe me, these kind of meditations do help in increasing our concentration. So next time you are feeling bored or you are feeling not like studying, just try and do meditation on your breath or on something like a drop of water which is drizzling from a tap, or even a second hand of a watch. Initially it would be very difficult, but once you start doing it, you would see that it would bring a certain kind of stability to your system and it would increase your concentration, right? So now let's begin. So this was the agenda previously. The agenda remains the same. We have done the basic principle of counting, we have done factorial, permutation, combinations, and we have done few test cases. Now what we would do is arrangement with repetitions, right? So we already know, we have taken an example of Sachin, right, that we can arrange it in 6 factorial ways. So there can be 6 factorial words which can be formed through Sachin, right? Now let's take a smaller word, right? Let's see how it is done. What do we mean by arrangement? So if there is a word called ABC, how many arrangements can be there? There can be an arrangement which is A, B, C. There can be an arrangement A, C, B, then B, A, C, then B, C, A, C, A, B, and C, B, A, right? These are the 6 arrangements, right? Because we had 3 words, it would be in 3 factorial ways, which is equal to 3 into 2 into 1, right? Which is equal to 6 number of ways, right? So you have seen that there is no repetition here, right? All the 3 words are different. A, B, C, all the 3 alphabets are different. Now let's look something like AAB. What we can do? We can make a AAB out of it, ABA out of it, and BAA out of it. Can we make further? If you just try and see, we cannot make further, right? So there are 3 arrangements. So how is it less than 3 factorial, right? Because we are arranging, we can use the basic principle of multiplication, basic counting principle of multiplication, which says it should be 3 into 2 into 1, which should be 3 factorial, right? But here we are getting just 3. How is it possible, right? So see, if we just denote one A by A dash, right, then we would get A dash B and A dash AB as different arrangements, right? But actually they are same, right? So we have to cancel out these 2 similar arrangements. Since the number of repeating words are 2, we divided by 2 factorial rather, right? So the number of arrangement becomes 3 factorial by 2 factorial, which is 3. So now if we take B triple A, then the number of arrangements would be 4 factorial into divided by 3 factorial, and the arrangements would be B AAA, right? This would be the first, then ABAA, then AABA, and finally triple A B. These would be the 4 arrangements. Try to make more and you would not be able to, right? So these are the 4 arrangements. So what we are doing, right, even if we don't know this formula, for a simple sum like this, we can count, right? We can count. Now, if this word become a 7-letter word, making these type of arrangements would become really tough for us. That's why we try to generalize things in basic principles. So these are basic principles of counting, nothing more than that. The fancy name permutation and combination is just to scare you, right? This is just basic principles of counting, right? So we try to formalize formula, we make a formula out of these basic principles of counting, right? So in general, we can say, if there are n items to be arranged such that A are of one kind, B are of another second kind, and C of third kind, then total number of arrangements would be n factorial by A factorial divided by B factorial by C factorial, right? So to put things in perspective, let's take this example. You have to find the arrangements of the word meditation, right? So just take 30 seconds and do it. Use this formula simply, right? Now you have understood the logic behind this formula as well. So I think remembering this formula would become much more easier, right? So try and do this. I hope that you have done it and you have done it correctly. So there are 10 letters, which means 10 factorial. T is repeating twice, which is 2 factorial. E is single, M is single, D is single, I is again repeating twice. So this would be an answer, right? If the choices are in this form, you can just stick it. If the choices are in solution form, you have to find the solution, right? So because 10 factorial is a big number, most chances are the choices are in this format, right? So just leave it like this. Now another important thing which comes in exam is dictionary placement, right? So there is a word Nokia, right? And you are making different arrangements from all the alphabets. You have to find the dictionary placement of Nokia, right? Since we have not done any dictionary placements before, I think most of you won't be able to do it if they don't have any previous idea, but still I would give you 2 minutes because dictionary placement questions are usually longer to do, right? So try and do this. You have 2 minutes for attempting this. let's see how to solve it. Now dictionary ordering means what, right? So dictionary ordering means there would be some words which are starting from A before there are some words which are starting from B, right? So there would be few words which are starting from A. Before that, how many total words would be formed? It would be 5 factorial, which is 120, right? So our answer should be less than 120. That's first checkpoint, right? Now let's see how many words are starting with A, right? Now we have fixed the first word. Now remaining, how many words are left? Remaining 4 words are left, right? So we have to fill these 4 words. This place can be filled in how many ways? 4 ways, right? This 3, this 2 and this 1. So how many words starting with A would be there? There would be 4 factorial words, which is 24, right? Next there would be words which are starting with, after A what would come? It would be I, right? Again there would be 4 factorial words, 24. Then starting with K there would be 4 factorial words, 24, right? So which means before we have words starting from N, we have 24 plus 24 plus 24, which are 72 words already, right? Now we start with N, right? Now there are words which are starting with N, then it would come A, right? Now there would be 3 alphabets, 3 things which are left, right? So words starting with NA would be how much? 3 into 2 into 1, 6, right? Then there would be words which are starting with NI, right? There would be words which are starting with NI. Again they would be 6. And then there are words which are starting with NK, right? Again they would be 6. Now we have words which would start with NO, right? Then there would come A, right? Then there are two blanks, which is I and K, right? So these would form 2 words. Then we have NOI, right? Then the word would be AK, right? And then it would be NOIKA, right? So this means we have 72 here, plus 6 plus 6 plus 6, 18 here, which is 90 plus 92. This is 93rd word and this is 94th word. So according to dictionary, Nokia would be placed at 94th position, right? So this is slightly tedious and slightly difficult to do in exam kind of environment, but with practice you would be able to ace it, right? So if this kind of question comes, I think you would be very confident that you would be able to do it if you put in around 1.5 minutes. So it's advisable to put that much time, because you would be able to score marks in these kind of questions, right? So here the answer is 94. I hope the basic is clear in this question. Now this question, a person starts from A, so A is this end, right? A is this end, and he wants to go to B, right? How many possible ways are there, right? I think I'll solve this for you, right? Because this is slightly tricky, right? So for going from A to B, either he travels horizontally and vertically, right? So he takes some steps horizontally and vertically. For example, how many steps are there which he wants to take horizontally? It would be 1, 2, 3, 4, 5, right? 5 steps vertically, and horizontally it would be 1, 2, 3, 4, 5, 6. 6 vertically, right? So if he takes 5 steps horizontally and 6 vertically, he would be able to reach B. So 5 steps horizontally, 1, 2, 3, 4, 5, and 6 steps vertically, right? So this is what, right? So he can also say H, V, 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 H, V, 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 and remaining 3H, right? So this is nothing but arranging this, how much? 6 plus 5, 11 letter word, right? How can we do it? It can be done in 11 factorial ways, divided by how much? 5 factorial and 6 factorial, right? Because VVs are there are 6 V's and there are 5 H's, right? So these would be the total number of ways in which he can reach from A to B, right? Again, so HH means he is firstly going from firstly taking this horizontal step and then going this vertical, right? So what he is doing is he is going something like this and this and this, right? And this way and this way and this way he reaches here. Then he takes horizontal steps to reach B. Similarly, he can take all the horizontal steps first and then all the vertical steps to get H and V, or he can take one horizontal, few vertical, then few horizontal, then vertical, right? So this is nothing but arranging this sequence, right? And how to arrange this sequence? It's 11 factorial divided by 5 factorial and 6 factorial, right? So this is basically about arrangements, right? Arrangements are very important. You would see most of the questions in CSAT are asked from this topic only, from arrangements, right? There are various varieties of arranging things, so there are various test cases. I have taken few test cases and most of them are previous year CSAT questions, right? So let's go through them one by one. I'll give you around 1 minute. So the good thing about P&C is once you are confident about the concept of permutation and combination and you are clear that how to solve the questions, you would be able to solve it in less than 1 minute, right? So let's see how to solve it. If we have to make 5-letter words from 5 vowels and 6 consonants such that word contain 2 vowels and 3 components, how many ways are there, right? So you have around 40 seconds to solve this. Try and solve this. So let's solve it. So we have to make 5-letter words such that it has 2 vowels and 3 components. So firstly we have to select 2 vowels out of 5, which can be done in 5C2 ways. Then we have to select 3 consonants out of the given 6, and then we have 5 things, right? 5 items with us. We have to arrange them. How do we arrange them? We arrange them in 5 factorial ways. So this would be the answer. Just solve 5C2 and 6C3. Whatever the answer is, that would be the answer, right? So I hope that you are clear with the concept. Now there is a slight tweak to this question. Again, 5-letter words, 5 vowels, 6 components, 2 vowels, 2 components are there, such that vowels are always together, right? Now the condition changes. There was no condition previously about how vowels are placed or how consonants are placed, but now it says vowels are always together, right? So just try and do it. 40 seconds for this as well. Now let's see how to do it. Again, we have to select firstly vowels and consonants, so this part remains the same, right? Now what we can see is initially consonants and vowels could be placed anywhere, right? But now vowels have to be together, right? Which means something like this, right? So if we consider these two vowels as just one entity, right? how many things are there? There would be 3 consonants. These vowels forms one entity, right? So there would be 4 items, right? The items would contain 3 consonants and an entity of 2 vowels, right? Which means these 4 entities can be arranged in 4 factorial ways, right? And these vowels which can be written as V1 and V2 or V2 and V1, right? Or it can be written as V2 and V1. So again, they are also permuting, or they are also arranging themselves in 2 ways, which means 2 factorial for this as well, right? So rather than 5 factorial here, we would have 4 factorial into 2 factorial, right? So the number of arrangements decreases, right? If you can see, 5 factorial is greater than 4 factorial into 2 factorial. So the number of arrangements would decrease. Now there is another question on the similar lines. It says that the vowels are never together, right? Now we have find the total number of cases when vowels are together as well as vowels are not together. Now we have found the number of cases where vowels are always together. How many cases are there where vowels are never together? This minus this, right? So answer of this question where vowels are never together would be A minus B, right? Now again this question only, it says vowels and consonants or such that no 2 vowels or consonants are together, which means, let me make a table here again. It has to be consonant, vowel, consonant, vowel and consonant. There is no other way out. So firstly we arrange 3 consonants and 2 vowels and then we arrange them in this way. How can this be done? The arrangement simply can be done in 3 factorial into 2 factorial ways multiplied by the number of selections, which was 5C2 into 6C3, right? So this would be the answer for this. Let's go to next question. This is a UPSC question which says each of the 2 women and 3 men is to occupy one of the 8 chairs. First the women occupy the chair from 1 to 4 and then the men occupy this chair. Find the number of ways in which this is possible, right? So again 40 seconds for this. Try and solve it. It's an easy one. So let's do it. First the women occupy 1 to 4 chairs. So it would be 4 C, how much? 4C2, right? Into 2 factorial, right? Or you can write 4P2 multiplied by how much? Left. What are the left number of chairs? They are 6. So it would be 6P3, right? So this would be the answer. Whatever the answer is, that would be the answer. Here the arrangements are also mattering, right? So we have to take care of arrangements as well. Now like next question says, how many ways are there to get a 3-digit number using 1 to 9 such that digits are in descending order? Again a minute for this, right? This is slightly tricky. See through it and just see if you can solve it or not. So let's see how do we, right? If it is simple that we have to make a 3-digit number out of 9 digits, we would have simply done it 9 into 8 into 7, right? Because we are bothered about the arrangements, which means 1 2 3 is different from 2 3 1, right? Or 2 1 3, whatever, right? So the number of 3-digit numbers which can be formed using 1 to 9 are 9 into 7 into 6, right? When the repetitions are not allowed, right? There can be questions where repetitions are allowed as well. So the number of digits would then become 9 into 9 into 9, right? If repetitions are allowed, right? So just to put things in perspective, how many 3-digit numbers are there if we are using from 0 to 9, right? So first digit can be from 1 to 9, right? First digit cannot be 0, so there are 9 ways. Second digit can be from 0 to 9, there are 10 ways, and then there are 10 ways. So total 900, and we know that there are 900 3-digit numbers. So this method works, right? So there is no doubt that permutation and combination does not work, right? Now it says that we have to do it in descending order, which means if we select 1 2 3, it should be arranged in this form 321, right? Which means out of 1 2 3, if we select, which means how many ways it would be? They can be arranged in how many ways? In 3 factorial ways, 6 ways. Out of these 6 ways, only one is essential, right? Only one is required, rest 5 are not required. Which means if total number of ways are this, what we are getting is 6 by 6, one way. So if total number of 3-digit numbers are this, we have to divide it by 6 to get our answer, right? I hope that you got the funda of why we have divided it by 6, because they are ordered pairs, right? They are ordered things. So we are only concerned about 3 2 1. We have to negate 1 2 3, 1 3 2, 2 1 3 and all that stuff, right? So out of 6 combinations, we are bothered about 1/6 of that, right? We are bothered about only one of it, which is 1/6 of the total combinations formed by any 3 digits, right? So it is divided by 6, right? The other way of thinking it is equivalent to NCR, right? It is equivalent to 9C3. You can see it is it equivalent to 9C3? It is. It can be written as 9 into 7 into 6 divided by 3 into 2 into 1, right? Which means if we select any of the 3 numbers out of these, there is always one possible way to arrange them such that they are in descending order, right? So you have to select, and there is just one and only one possible way such that we can arrange them in descending order. There cannot be two possible ways to arrange them in descending order. So if you use this logic, you would also get the right answer. Let's go to next question, which says group containing 3 boys is to be formed from A, B, C, D, E such that no group such that, and the question, it has C is always, group has C such that C is always selected, right? Find the numbers of such group. Now we have to just select people, right? We are not bothered about the arrangements. We already know that C is always there. We have to just select 2 people out of 4, which means it is 4C2, which is 4 into 3 by 2, which is 6 ways. 4C2 is 6. So the number would be, there are 6 such groups. Can we write 6 such groups? Yes, we can. It would be C is always there, right? It would be either AB, then C is there. It would be AD and CAE. This is one. Then there is CBD, CBE, right? And finally there is CDE. So these are the 6 groups which can be formed if C is always there in each of the group, right? So slight extension of this question, which says again a group of 3 boys have to be formed from A, B, C, D, E such that C and D are always together. Find the number of such groups, right? So again 1 minute to solve this. Try and solve this and then we'll do it together. As you can see, we are not using much of NPR, NCR here. We can, but as far as possible, if they are not required, just not use them, right? Try to use basic principle of multiplication, right? Even you would see that basic principle of addition is not used so much as basic principle of multiplication is. So let's see how to do this. Now it says C and D are always there, are together, which means if C and D are there, they are together, and there can be possibility that C and D are not there, right? If C and D are there, how many possible groups are there? So the third person can be A, B or E. So there are 3 possible groups if C and D are together. If C and D are not together, how many are left? A, B, E. So there is 1 possible group. So total number of groups would be 4, right? This is a simple question. Now this was the next question, which is 3 people are to be selected from A, B, C, D, E such that no group has both C and D together. Find the number of such groups, right? So this is a UPSC question. So again 1 minute for solving this, and then we'll do it together. So let's do it. Now C and D such that no group has C and D together. There are few of the methods which we can do, right? Firstly, let's see the basic method of counting. Let's say a group has C always, which means the other two members would be from A, B and E, which can be done in three ways, right? It would be 3C2, which is equal to 3 ways, right? Similarly for D, again it would be 3 ways, right? Now there can be a group where both A and B are not together, which the group would be ABE, right? So ABE would constitute one group. So total number of groups would become 7. There is an alternate way, right? How many groups can be formed from these 5? They would be 5C3, right? Which is equivalent to 5C2, which is 10, right? These are the total number of groups. If we subtract from this all those groups which has C and D together, we are through, right? So how many groups has C and D together? We have seen that if C and D are together, how many groups can be formed? They would be 3, right? So the total, our answer would be 10 minus 3, which is equal to 7, right? I hope that you are clear with both the methods. So whichever seems to be convenient to you, you can use that. Next problem, we have done this kind of problem before, so I am skipping this. I'll just read it and I'll write an answer. In how many ways can 6 players be arranged in a line such that 2 particular players are always together? So 2 particular players, let's say A, B, C, D, E, F, and C and D are always together. So we make them as one bundled group. How many items would be there? 1, 2, 3, 4, 5. 5 bundled items would be there. So 5 factorial, and these 2 items can permute amongst themselves. So 5 factorial into 2 factorial, which is equal to 240. Now this is an important question, right? This was again question asked in UPSC. There are 6 people and we have to arrange them such that 3 girls and 3 boys alternate, right? How do we do it? So there can be G, B, G, B, G, B, right? This can be one arrangement. The another one could be B, G, B, G, B, G. So you have to be cognizant of both the arrangements. The number of ways of arranging the first would be, so the G's can be arranged in how many ways? 3 factorials. B's can be arranged in how many ways? 3 factorials, right? So the number of arrangements from first would be 3 factorial into 3 factorial, which is 36, right? And number of from the second way is 36. So total would be 36 plus 36, right? So you have to see that in an arrangement either B can come first or G can come first. So you have to keep that in mind. If G comes first, then this would be the kind of arrangement. If B comes first, then this would be the kind of arrangement. So the number of arrangements would be 3 factorial. Girls can be arranged in 3 factorial ways and boys can be arranged in 3 factorial ways in each of the cases. So total cases would be 72. Next question says 2 dice are rolled, 3 dice are rolled. What is the possible number of outcomes such that at least one die shows the number 2, right? I'll give you around 1 minute to solve this, then we'll do it together. So let's do it. The simplest and the easiest way is, how many ways, how many possible outcomes can be there? The possible outcomes can be, first die can give 6 outcomes, second die can give 6 outcomes, and third die would give 6, which means total outcomes can be 216. Now all those outcomes in which 2 is not at all there would be 5 into 5 into 5, right? Which means 125 such outcomes. If we subtract these two, we would get all those outcomes in which at least 1 2 is there, right? So what we have done is, we have found the total number of outcomes. We have found those outcomes in which 2 is not there at all, right? If we subtract these two terms, what we would get? We would get the number where there are at least 1 2, right? So this is the most simple way out. The other way out is, you start calculating, right? So if there is 1 2, there can be 1 2, the number of cases would be, so that 1 2 can be in any of these 3 dies. So there are 3 ways of getting that 1 2 multiplied by 5 outcome on the die which is not showing 2, and 5 outcomes on the another die. So which means total of 75 ways. 2 2s, it would be, on which out of these 3 there would be 2 2s, so it would be 3C2, and the third die can come up in 5 ways, which means 15 ways. And 3 2s, it would be obviously 1 way. So if you add it together, it would again give 91, right? So the second method, the first method was not intuitive, right? It was intuitive, and the second method was methodical, right? It is how we think, and the first method is how it is easy to solve, and first method I would say is an intuitive method, right? So you can solve using any of the two methods. I would prefer the first one. Next question, again a CSAT question. 2 men and 1 woman boards a bus having 5 seats, out of which 1 seat is reserved for ladies. How many arrangements are possible, right? Again, this is a simple, so the questions of permutation and combinations are not tough. It is just that they are confusing, right? Try to solve it and use your brains to solve that. It would be an easy one. So let's see how to do it. 2 men and 1 woman board a train which has 5 seats, and 1 seat is reserved for ladies, right? So there can be 2 cases. Case 1 is when the women sit on seats reserved for ladies, right? So she can sit in one way, and men can sit and arrange themselves in how many ways? Remaining seats are 5 and 2 men are left, so 5p2, which is 4 into 3 is equal to 12 ways. Case 2 is when the lady does not sit on the seat reserved for ladies, which means we have 3 people and 4 seats. We can arrange them in 4p 3 ways, which is equal to 4 into 3 into 2, which is equal to how much? 12 to the 24, right? So the total number of ways would be 12 plus 24, which is 36, right? So 36 would be the answer for this. So I think we would wrap up our session here, right? There were few questions more on this session which we would continue over our next session, because the session is becoming too lengthy and it would be becoming overwhelming for you as well, right? So we would wrap up here. Again, to put things in perspective, I would say you have to practice a lot of things in permutation and combination. Questions are not difficult. Questions which comes in CSAT or bank PO or any other exam, even your placement exams, are not that difficult if they are from P&C topic. Only thing is they are slightly tricky. You have to just catch hold of that trick and solve them, right? So here I hope that you have understood the basic concepts and have seen few test cases, and you would be able to ace all the questions on CSAT, right? Wishing you all the best, and thanks for watching this video.